All right, so 3.3b. You might remember that we said that the limit of two things added is the same thing as the limit of the first thing plus the limit of the second thing. You don't necessarily need to write this down because we've written it down already, but it's good. It's a good reminder. So what was this called? Like there was a bunch of them. They were all called limit laws, right? So it's also true for minus. So limit distributes past, plus, and minus. We've known that for a while. Okay, then earlier this week we learned that derivative behaves the same way with plus and minus. So you could distribute derivative past, plus, and minus. So I'm just summarizing that limit goes past plus and minus, and so does derivative. Okay, then we learned with limit laws that limit goes past times. So this was one of our limit laws, that you could take a limit past a multiplication sign. So limit goes past plus and minus, derivative goes past plus and minus, and limit goes past multiplication. So it kind of seems like derivative should go past multiplication. Kind of seems like this should happen, and I'm hinting that it's not true. It's not true, but it seems like this should be true. But it even makes me kind of nervous to write down. It's not true. This is not true. So when you have two things multiplied together, and you're trying to take the derivative of it, at some point you're probably accidentally going to take the derivative of the first thing times the derivative of the second thing. But that's the wrong way to do it. So just to reemphasize, this is not true. Okay, so what is true is called the product rule. It's called the product rule because multiplication is a fancy way to say multiplication is the word product. So the product rule tells you how to correctly take the derivative of two things multiplied together. And f and g are just arbitrary names. The functions could be called anything. So I'm going to refer to f as the first thing, and I'm going to refer to g as the second thing. So the way it works is you take the derivative of the first thing, and then you multiply by the regular second thing. And then there's a plus sign. And then you take the derivative of the second thing, and multiply by the regular first thing. Okay, so it's when you're taking the derivative of two things multiplied, tempting to do this. This is not going to give you the correct slope. This is what will give you the correct slope. So the way I say it is derivative of the first thing times the regular second thing plus derivative of the second thing times the regular first thing. Okay, so sometimes I just write stuff down and expect you to believe that it's true, but I'm going to show you that this is true. But I'm going to show you that it's true in the official math way, and that's called a proof. So that word kind of makes you cringe because you did proofs back in geometry and they were not a lot of fun because you didn't necessarily know what was going on. So try to not have this word associate terribleness. But what I'm about to write down is very mathy. Okay? but try to follow along. Okay, so if I'm going to take the derivative of something, the way to do it is to do this. The official way, the definition of the derivative. If we don't know how to take the derivative of something, we go back to the hard way to do it. The official definition way of doing it. We've got a bunch of shortcuts, and we have this shortcut, but right now we're trying to prove that this shortcut is true, and so we're going back to the old way of doing the derivative. Okay, now in this case, what is the function that we're trying to take the derivative of? The whole thing f times g, right? So we're trying to take the derivative of f of x times g of x. So when you do a derivative, it's the limit as x approaches a of f of x minus f of a all over x minus a. But in this case, the f of x that we're derivating is that whole mess, that function. Okay, and then f of a would be f of a g of a. Okay, so in order to prove that this is true, I'm just going back to the definition, and this is how you take a derivative. Okay, now I'm going to separate this out. I'm going to leave a bunch of space in the middle. I've got f of x, g of x, and then at the very end I'm going to have minus f of a, g of a. And on the bottom, x minus a. So far it's identical to this. I just left a big space in the middle for some reason. Okay, the reason I left a big space in the middle is I'm going to add 0 in there. Okay, but it's going to be a very strange form of 0. Do you agree that I could put plus 0 in there and that wouldn't change anything? Okay, so I'm just going to put plus 0 in this space. But here's the 0 that I'm going to use. It's plus f of x g of a, and then minus f of x g of a. Okay, so these cross out and make 0. So that's why I'm allowed to stick them in there. If you have minus something plus the same thing, it's worth nothing. So that's why I was allowed to do that. Okay, now why I did that, you really don't see yet. I just see the end of it, and that's why I need to do that. So maybe after we go a little bit further, you'll know why I did that. But the only thing I'm expecting now is that you agree that I'm allowed to do that. So I've got a minus and a plus. They just cross out, so that's why I'm allowed to do it. Okay, so then next, I'm going to factor an f of x out of these two. All right, so I've got the limit as x goes to a of f of x times g of x minus g of a. So that's just the first two terms. And then for the second two terms, I'm going to factor out a g of a. So that's g of a times f of x minus f of a. Okay, so after I wrote that 0 in the middle there, I just noticed that the first two terms had f of x in them, so I pulled out the f of x. And I also noticed that the second two terms both had g of a in them, so I pulled out the g of a. So that's just factoring. Okay, now when you have two things added, divided by something, you can split that up. So this is f of x times g of x minus g of a. all over x minus a plus g of a times f of x minus f of a all over x minus a. Okay, so often we go from this step to this step. So if two fractions have a common denominator, you can add them together, right? So that's what I'm looking at here. These two fractions have a common denominator, and then when you add them together, the denominator just stays. So if you take 1/4 plus 2/4, the final answer is 3/4. So if you take something over a plus something over a, the final answer is just going to be over x minus a. Sorry, I said over a, I meant over x minus a. Okay, so a lot of times we go from there to there. Less often we split it up this way, but it's still legal. Like you could split up 3/4 into 2/4 plus 1/4. So that's all I did there. I split this fraction up into its two parts. Okay, and I still have the limit in front of that. Okay. Okay, now I'm going to take this f of x and multiply it by this fraction. So all that's going on here is, this is like f of x over 1, right? And if I take f of x over 1, if I times across the top, then I'll get this. And if I take 1 times x minus a, I would get x minus a. So more often we go from this step to this step, but that explains why we're allowed to go from there to there, pulling the f of x out. Okay, and then I'm going to do the same thing with g of a here. This is g of a times f of x minus f of a all over x minus a. Okay, now I'm just going to do a bunch of limit laws. So this limit can go past this plus. So I could take the limit of that plus the limit of that. And also the limit can go past times. So then I'm going to take the limit of that times the limit of that plus the limit of that times the limit of that. Okay, so that's the limit as x goes to a of f of x times the limit as x goes to a of g of x minus g of a all over x minus a plus limit x goes to a of g of a Okay, so that was just a bunch of limit laws. All right, what's going on here? What is the limit as x goes to a of g of x minus g of a all over x minus a? It's a derivative, right? It's a derivative of what function? G at what number? A. So this is G prime at A. So I'm skipping, I'll talk about what's before the times later. But after the multiplication is G prime at A. And there's a plus sign. Then this one's a little bit tricky, so let's do what's after the time sign now. What's this? The derivative of f at A, right? So that's f prime at A. Okay, so I recognize these two limits as derivatives. So I could write down what they were. Okay, now remember, A is a number. We're taking the derivative at a particular number. So if A is a number, then G of A is a number, because we're plugging A into the function G. So that's the Y value, whatever that number is. Okay, so this is just the limit of a number. So what is the limit of a number? Just the number. So that's G of A. Okay, now I've broken it down to this limit. This is the hardest limit, but it's not too bad. If in order for the product rule to work at A, in order for there to be a derivative at A, then f has to be continuous at A. Let me say that again. If there's going to be a derivative, if it's differentiable, it has to be continuous. So we're assuming that f is a differentiable function because we're taking the derivative of this. So that means f is a continuous function. Because if it wasn't continuous, it wouldn't be differentiable. That's one of the ways you can be not differentiable. Okay, so since you're continuous, that means the limit towards A is the same as f of A. Because that's the definition of continuous. So since f is continuous, this limit is f of A. Okay, so I've got my final answer as the derivative of G times regular f plus the derivative of f times regular G. And that's the product rule over here. Switched around a little bit, right? But it doesn't matter because a plus sign, I can switch across a plus sign, right? Okay, so I just showed that the derivative at A is this, but it's true for any number. So that means the derivative overall is this. And then, like I said, I could switch that around. The derivative of the first thing times the regular second thing, plus the derivative of the second thing times the regular first thing. Okay, so now you believe it's true, sort of. Haha. Okay. So now that you believe it's true, we're going to use it. So this is the product rule, and it tells you how to take the derivative of things that are multiplied. So let's say we have a function that is x cubed plus x plus 1 multiplied by x to the fourth plus x squared plus 1. And we want to find h prime of x. Okay, so you would suspect that we're going to use the product rule because I just taught you the product rule. But other times the problems are all going to be mixed up, right? So why should I use the product rule when I'm taking the derivative of this function? Because this function is a function times another function. So you use the product rule whenever you're taking the derivative of two things multiplied together. So that product rule applies here because we are taking the derivative of a function that is two things multiplied together. Okay, so since we're going to use the product rule, we'll just use that rule over there. Okay, so what's the first function? X cubed plus x plus 1, right? And the second function is x to the fourth plus x squared plus 1. So the way the product rule works is you take the derivative of the first thing, so all this is here is the derivative of that. So the derivative of the first thing times regular second thing then there's a plus sign. So the way the rule goes is it's the derivative of the first thing times the regular second thing, and then plus the derivative of the second thing. So this is just the derivative of the second underlined thing here times the regular first thing. Okay, so I'm just following the rule. Derivative of the first thing, regular second, plus derivative of the second, times regular first. Is everybody okay with that? Okay. So, if this is a free response question, please do not go any further. Don't FOIL this out. Don't distribute it out. We did all the calculus. This is the derivative right here. And it's a usable derivative. I could plug a number into here in all these places and figure out the final answer for the number. Okay, so don't worry too much about simplifying, because this would be really nasty to simplify, right? You have to distribute the 3x squared, distribute the 1, distribute the 4x cubed, distribute the 2x, collect like terms. It would be a pain in the butt. So if it's a free response question, just stop. Once you do all the calculus, and right here all the calculus is done. Okay, so what does this formula here do for us? If we plug a number into this and we get a number out, what does that number that we get out mean? Yeah, you know. Give it a shot, Brittany, you know. It's the slope of what curve? This curve, right? Yeah, so if we graph this curve, plug a number into here, this tells us the slope of that curve. It's just now we had to have this new rule on finding the slope function, because this function was two things multiplied together. All right. Okay, so you had a limit law. That said the limit of two things divided was the limit of the top thing divided by the limit of the bottom thing. I'm just writing this down informally, so that's why I'm leaving out the x minus a, because we've already written it down officially. So you had a limit law that said this. Was this always true? wasn't always true. When was it not true? When the limit of g was 0, right? So this is true unless the limit of g is 0. And if the limit of g is 0, remember, it's tempting to say that the limit does not exist, but that's just plain not true. It means that limit laws didn't work, and you have to try something else. So you do factoring or rationalizing or any of those big limit tricks that we learned. Okay, so this is a limit law that's true most of the time. So because of that, it's tempting to think that the derivative of two things divided would be the derivative of the top thing divided by the derivative of the bottom thing. But this one's not true either. Okay, so at some point you'll probably make this mistake. You'll be taking the derivative of two things divided, and you'll accidentally just take the derivative of the top and the derivative of the bottom and divide them and think that that's the answer for the derivative. But, so I'm warning you, that's wrong, it's not true. And you suspect it would be true because it works for limits, but it just doesn't work for derivatives. Okay, so what does work is called the quotient rule. Quotient is the fancy word for divide. Just like product is the fancy word for multiplication. So here is the quotient rule. When you take the derivative of two things divided, okay, so I'm going to refer to f, because f and g are just arbitrary names. The functions could be called anything. So instead of calling them f and g, I'm going to call this the top function and that the bottom function. Okay, so the way it works is you take the derivative of the top, times the regular bottom, and then there's a minus sign, and then you take the derivative of the bottom times the regular top, and then you divide by the regular bottom squared. Okay, so just to help you out with your memorization, the top of that fraction is identical to the product rule, except there's a plus sign in the product rule. And then you just have to remember to divide by the bottom function squared. Okay, if it's okay with you guys, I'm going to just ask you to believe me that this is true. I'm not going to show you it's true. I mean, if anybody wants me to show you, I can. Are you sure? Because that was a lot of fun earlier with the product rule, right? Okay, all right. Thank you for being nice. I know you'd like to see it, but we just don't have time. So, okay, so we're just going to assume this is true. We're just going to practice. Okay, so my function is going to be y equals x squared plus 5x plus 1 over x squared. And we're going to find the equation of the tangent line. At x equals 1. Okay, so if you're going to find the equation of a tangent line, what is your final answer going to look like? If you're looking for the equation of a line, how do you go about doing that? Yeah. Yeah, it's going to be something with y equals mx plus b, right? That's how you write the equation of a line. This just happens to be a tangent line. Okay, so if you're going to use y equals mx plus b, you need to know what the slope is, right? Anytime you write the equation of a line, first job is to figure out what the slope of the line is. Okay, so how do you find the slope of a tangent line? You take the derivative, right? Because the derivative is the equation that'll output the slope for you. Okay, so first thing we have to take the derivative of this function. Okay, now I just taught you quotient rule, so that would lead you to believe that we're probably going to use quotient rule, but why would I use quotient rule when I do the derivative of this? Because there's two functions divided to make up this other function that I'm taking the derivative of, right? So anytime you have the derivative of two things divided, you have to use that rule. So that's why that rule is applying on this problem. Okay, so to figure out the formula for the derivative, the y prime, the way the quotient rule works is it's the derivative of the top. So that's 2x plus 5. Everybody okay with the top derivative being 2x plus 5? Okay, so it's the derivative of the top times the regular bottom minus derivative of the bottom times regular top all over bottom squared. Everybody following okay? Okay, so remember, if this is a free response question, stop here. We have done all of the calculus at this point. If the question just says find the derivative, you can stop here if it's a free response question. But sometimes it's a multiple choice question and they simplify things out for you, so I don't want to ignore the simplifying. Like on the last problem, I ignored it. But this time, let's practice simplifying, just in case it's a multiple choice problem that has a simplified answer. Okay, so I'm going to distribute the x squared. So that gives me 2x cubed plus 5x squared. Just multiplying x squared times 2x and x squared times 5. So I distributed the x squared. Now I'm going to distribute the negative 2x. So negative 2x times x squared is negative 2x cubed. I already wrote my negative sign. Minus 10x squared minus 2x. So I just distributed the 2x into there. And then what do you do with exponents in this situation? Multiply them, right? So that's 2 times 2, which is 4. So x squared squared is x to the 4th. Okay, so now I'm just going to collect like terms. The x cubes cross out. I've got 5x squared minus 10x squared. So that's negative 5x squared. And there's also a minus 2x up there. Then I could pull an x out of the top. So then after I pull out that x, this x can cross out with one of those x's. Oops, I got ahead of myself, didn't I? I was thinking about what was going to happen. This is going to stay the fourth in this step. Sorry about that. And so then this is the third power in that step. Okay, so this is as far as I would go probably with simplifying. But I'm going to show you that you could divide the x cubed into both of those, right? This is not usual simplification. But you could do that. So then after the minus, that's 2x to the negative third, right? And before the minus, it would end up being x squared on the bottom if one of the x's canceled. So that's negative 5x to the negative 2. Okay, so like I said, simplifying would probably stop here. The multiple choice answer would probably be this. But these were two other legal steps. Now the reason I went to here is I want to go back to the original and divide the x squared into there. So this is the original, right? Not the derivative. Still the original. Okay, now let's take the derivative of this. So this is the original, right? This is the derivative. What's the derivative of 1? 0. The derivative of this is negative 5x to the negative 2, right? And the derivative of this is negative 2x to the negative 3. So this would have been an easier way to find the derivative on this problem. See how it matches up? So the reason I did that for two reasons. Number one, I wanted to convince you, sort of, that the product rule was true. Or sorry, the quotient rule was true. So I did the derivative two different ways. One using the quotient rule and one not. So that kind of convinces you that it's true. And also, I wanted to work with the negative exponents and practice that as well. Okay, so this over here was method 2 for finding the derivative, right? And this over here was method 1 for finding the derivative. There's some problems where you'd have to use the quotient rule. You wouldn't have method 2. So that's why the quotient rule is important. Okay, so let's get back to the problem. The problem is find the equation of the tangent line, right? So why did we need this derivative? To get the slope of the tangent line. Okay, so now we plug 1 into that formula, and that'll give us the slope at 1. Okay, so plugging 1 into, I'm going to go back to this one. So I went back to here. That's the derivative, right? So is this. You could plug it into here if you wanted to. Doesn't matter. They're both the same formula, just written in a different way. Okay, so but I decided to go back to here because that would be the answer I'd probably end up with in a normal instant. Okay, so that comes out to -7, right? Come on. Come on, you can do it. Okay. All right, so that means the slope is -7 for the tangent line. Now, in order to find the y-intercept, I need a point that's on the graph, right? The point that I'm talking about is 1 comma something, because it said x equals 1. So how can I find the something? Yeah, Michael? Plug it into the original function, right? The original function gives you the y values. The derivative function gives you the slopes. That's where we got the -7. But I'm going to plug the 1 into the original. So 1 squared is 1 plus 5 plus 1. So that comes out to 7 over 1 squared is 1, so 7. So the y value is +7. So I got that +7 plugging into the original y equation, because the original y equation gives you the y value. Okay, so now I can figure out the b. If I put a 1 in for x and a 7 in for y. So the y-intercept comes out to 14. So final answer for the equation of the tangent line is y equals -7x plus 14. Okay, so big topic for today was how to take the derivative of a formula that's two things multiplied. That's the product rule. And then how to take the derivative of two things divided. That's the quotient rule. Okay, I just want to remind you that the cube root of x, another way to write that is x to the 1/3 power. So the square root of x is x to the 1/2 power, right? But then x to the -3rd is 1 over x to the 3rd. So sometimes these things, people get them mixed up. So those types of fractions and exponents happen on the homework, so I wanted to make sure you remembered that. All right, that's all I got. Song tomorrow.